Okay, so today we're going to talk about absolute value equations. I started off with a very simple absolute value equation. I have the absolute value of x plus 3 set equal to 4. We're going to talk about this equation in two ways. We're going to talk about it algebraically and graphically. I like to start off talking about it graphically because it makes more sense to see a picture for me. So with this situation, I want you to think about the absolute value of x plus 3 is going to be the absolute value graph, which we know is the shape of a V. And we're going to put that into y1 on our calculator. The 4 is going to be a linear graph. We're going to put that into y2 on our calculator, and it's going to look like a constant line. Okay? And then the equal to sign simply says we're looking for where these two graphs intersect. So I want to jump from this screen to my calculator. And in y equals, like I said, I put y1 as the absolute value function of x plus 3. And in y2, I put the linear function of 4. And when we graph these two functions, we end up seeing the absolute value I discussed and the linear piece. And we're looking for where these two pieces intersect. So if you look at the graph, you see your line. You see your absolute value. Hopefully we understand that they intersect at two positions. And we're going to use our calculator skills to identify those two positions today. So we're simply going to hit second and trace for our calc function. And inside here, these lists of words, we're looking for the intersect. So we want to go to 5. That takes us back to our graph. And if you'll notice at the bottom of your screen here, it's asking for first curve. That simply means move your cursor to your first intersection point. It takes a little while, so give me a second. Once you get very close to your intersection point, you're going to hit enter on your absolute value function. It's going to jump to the linear line. It's still very close to my intercept. I want to get a little bit closer, and I want to hit enter. Then it's going to say, would you like me to guess? And we obviously want the calculator to guess, so hit enter. And we get an intersection of an ordered pair -7, 4. We're only concerned with the x value of -7, so I want to write that down here. That is one of my solutions. I'm going to repeat the process to go through and find the intersection on the right side. So second, trace, intersect. Move my cursor close to my right side intersection. I went too far, so I got to come back just a little bit. I want to hit enter on my absolute value. It jumps to my linear, so I want to get closer on my line. Hit enter. Hit enter again on guess. And again, the order pair 1, 4, we only care about the x value. So a solution is going to be when x is 1. So we just found the answers to this absolute value equation graphically. X is -7 and x is 1. It's where our two functions intersect. I'm going to take the same process now and apply it algebraically. So I'm going to go back to my screen. I'm going to go to a new picture. And we're going to solve this exact same function in which we found the answers to be -7 and 1. We're going to find those exact same answers, but this time algebraically. So if you want to solve an absolute value function algebraically, you have to first make sure your absolute value is isolated. That means look at the function. There should be no coefficient to your absolute value and no adding or subtracting behind the absolute value. So in this case, we are isolated. The second thing is to make two problems. First problem, you simply drop off your absolute value bars. The second problem, we drop the bars off and we always multiply the right side by -1. This shows both the left and the right side of a number line, a positive side and a negative side. Now, if I solve both of these minor, tiny equations, I should get my two answers. So when I subtract 3 on this piece, I get x equals 1. I'll multiply first here to get my right side to be a -4. Then subtract 3, and I get x to be a -7. And those are my two solutions. And the great thing about this is these were algebraically calculated, but if we notice, the algebraic is the exact same answer we got from the graphical calculation. So we have just proved that algebraically and graphically we have the exact same answers to this function, and that would be x is -7 and x is 1.